Hi everyone, welcome to my video. We're going to work through past Edexcel paper, GCSE Mathematics, and it's paper 2, which means the calculator paper, and that is in from November 2013. So let's move on. Question 1. Use your calculator to work out the value of that expression. So, the button that I like to use on my calculator looks like that. And what that does is it gets a fraction for you. Then you can type the top thing into your fraction by using the square root button. Okay, so square root button and then 7056. Then you can press the down arrow to move on to 0.35 times by 12.8. Then you press equals and it gives you the answer of 18.75. To get it as a decimal, you might need to press the extra button that says SD like that. Okay, it converts. Write your answer to part A, correct to one significant figure. So, one significant figure, there's the first significant figure. You look next door at the 8, which is going to round the 1 up to a 2. But you can't just put the number 2 because you're rounding 18.75. You need the place value holder to make it 20. That's your answer. Clear ink. Question 2. Pavel and Katie share some sweets in the ratio 3:8. So, poor Pavel only gets 3 sweets every time that Katie gets 8 sweets. Okay, don't ask me why. That's an agreement they've come to. Katie gets 32 sweets. Okay, so 3 to 8, Katie has 32. And I guess we want to know how many Pavel gets. So, to get from 8 to 32, how many lots did we need to do? What did we times by? So you've got your calculator, so you can figure this out by going backwards, doing 32 divided by 8. And that's going to give you 4. You might have been able to do that in your head. So we times this side by 4 as well. We can simplify ratios just like we simplify fractions to give you that Pavel gets 12 sweets. Right, Katie also has a tin of chocolates. There are 80 chocolates in the tin. 45% of the chocolates have toffee in the middle. Okay, let's just write that down. 45% toffee. Work out the number of chocolates that have toffee in the middle. So basically we started with 80, 45% have toffee, so we want to know 45% of 80. Now on a calculator paper, what I would do is I would say 45 as a decimal is 0.45, and this is your key number. This is called your multiplier. You can just do 0.45 times 80, your calculator will give you the answer. So handy tip if you ever want to use your mobile phone for calculating the percent of something. Okay, so the answer is 36. Clear ink. Question 3. Bill has some counts in a bag. Okay, you guys all know I like my diagrams, especially for counts in the bag. 3 counts are red. 1, 2, 3 are red. 7 of the counts are blue. 1, 2, 3, 4, 5, 6, 7, and the rest are yellow, so we do not know how many yellow we have. Bill takes at random a count from a bag. Okay, so he takes one out. The probability he takes a yellow is 2 out of 7. Okay, how many yellow counters are there in the bag? So, 2 over 7 yellow. So that means if there were 7, then there are 2 yellow. So that means that there's 5 not yellow. Okay, for every 7. So 2 yellow. It's a ratio question again, really. 5 not yellow. Not yellow. So we're talking about the ratio 2 to 5. And we want to know how many not yellow we have. It's very, very similar to the one we've just done. Let's count up how many not yellow we've got in the real bag. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or you could have just done 3 and 7, but that's your choice. Okay, so we had 5. You can times by 2 to get to 10. So you can do 2 times 2 to get to the fact that there are 4 yellow sweets in the bag. Or, as the question says, yellow counters. You do not want to start eating counters, believe me. Right, question 4. The diagram shows a solid prism. On the centimetre square grid, draw the side elevation of a solid prism from the direction shown by the arrow. So we have a handy arrow here, okay? And we're also given some instructions. We're given how long each width is. Okay, now the cool thing is about these diagrams is it helps you visualize things in real life. You do it every day, everyone does it. Say you're walking up forwards to a set of stairs, you might see that in front of you. But you still know it's a set of stairs because you're clever. Okay, because your brain figures out, well actually, that's just from the front, but from the side, it looks like that. You see? It's the same kind of thing going on. So you've got to imagine that you're stood here looking this way. What would you see? Well, you'd see this front bit and this front bit, just like steps. Okay, so we have to draw this and this above it. So the first part is 5 across, 2 up. So let's draw 1, 2, 3, 4, 5 across. And what did I say? 2 up. Made an error. 5 across, 2 up. Let's put it here. You would use a ruler. You know that. Okay, so that is this bit. Let's do it green so we can distinguish. And above it, you've got it going up 3 more. Okay, and it's still 5 across. So we go up 3 more. That's the next step, which we can just do that. Okay, so that's what you'd see. That's it. Job done. That's 2 marks for being able to visualize things. Ben goes on holiday to Hong Kong. In Hong Kong, Ben sees a camera costing Hong Kong dollar £3,179.55. In London, we've got a comparison question here. So this is Hong Kong over here. This is London over here. In London, the camera costs 285 quid. And let me guess, he wants to know whether to buy it in Hong Kong or in London, which is a fair question for Ben to ask. Maybe one day you'll be asking yourself the same thing. It might not be a camera, it might be something else. But you need to decide if to buy it abroad or in the UK. The exchange rate is a key bit of information. Exchange rates change all the time, so you need to be careful. Hong Kong dollar, £12.30 is £1. Ben buys the camera. Oh, he's made his choice. Didn't even think about it. How much cheaper is the camera in Hong Kong than in London? So it's a comparison question. Do we need to give our answer in pounds or Hong Kong dollars? It doesn't say. No, it doesn't say. Okay, fair enough. So, 285. Well, we know that 1 Hong Kong dollar is, we know that £1 is 12. I'm just going to use dollars if you don't mind. You know what I mean. 35. We want to know how to multiply up. So to get from 1 to 285, times by 285. We have a calculator. So on your calculator, do 12.3 times 285 gives you 3. This is Hong Kong dollar. £3,505.50. So now you need to do a subtraction. This was the cost in London. Take away the cost that Ben paid. He's made the right choice. Good old Ben. What a guy. Okay. I've still got this on my calculator, so I'm just going to do take away, and then 317.9.55, and he has saved himself 325.95 Hong Kong dollars. What a guy. Okay, that's what no maths can get you. 325 Hong Kong dollar saving. Okay, right, moving on. Question 6. There are 130 adults at a language school. Each adult studies one of French or Spanish or German. 96, you can do these in diagrams, you know. I think I'll show you this because I've not shown it you before. So it's called a two-way table. You might have seen one before. So we can do here the language, and we're going to have going across French, Spanish, German. Okay. Anyway, 130 adults. Each adult studies French, German, Spanish. 96 of the adults were women. So you've either got women or men. Okay, so this is gender. Women, men. Okay. Now, if you're in, say, this column, then that's how many women do German, for instance. So let's fill in what we know. And by the way, we always have totals on the sides as well. So this is a two-way table. 96 of the adults were women. So that means that if you add up all the women, you get 96. That's your total. 12 of the women study French. So 12 women study French. Let's tick them off. 73% of the adults study Spanish. Okay, so the total people studying Spanish is, what do we say, 73. 55% of the women study Spanish. Not percent, 55. 9 of the men study German. So that's all the info that we are given. Let's find out what it wants. How many adults study French? So what we want to know is the total here. Right, so we'll get to it by several things. If we knew this one, we could just add it here to 12 and get the answer. So let's work out what we know from each thing. This missing number here for German adds together with 12 and 55 to give you 96. So in your calculator, do 96 minus 12 minus 55. Or in your head, it's up to you, but I wouldn't risk it. And that gives you 29. Okay, so 29 people here. By the way, guys, I'm sorry, look, 130 adults. So that means that we can put 130 the total number of adults. Okay, anyway, on to 9 of the men German and 29 women German. So that means that we can add 9 and 29 to get 38. And now we've actually come about it a different way. There's different ways to get there. This missing mystery number is going to add together with 73 and 38 to give 130. Okay, so we can do 130 minus 73 minus 38. 130 minus 73 gives you 19. So that means that that's all you need to know, but then there's 7 there, and you could fill in all the rest. Anyway, so the answer is, how many of the adults study French? 19. Okay, so you make your answer stand out nice and clearly. That's your job to do. I can't set it out for you. Plants are sold in 3 different sizes of trays. Let me guess what I'm going to do. Diagram. Small trays hold 30 and cost £6.50. Medium tray, 40 plants. So let's call it med for median. Costs £8.95. And also, large tray of 50. cost $10.99. Okay. So the info in the diagram, I like to see it for some reason. Kaz wants to buy the tray of plants that's the best value for money. Which size of tray should she buy? So let's figure out for each one how much one costs. So we're going to compare cost of one for each. So 30 costs £6.50, so you're going to do £6.50 divided by 30 on your calculator to give you 21.6 pence. 0.22, well, you never know what it's going to be like. 1/6 reoccurring. Put it like that. Medium is going to be 40 for $8.95. So to find out one, do $8.95 divided by 40, and that costs 22.3p. Your calculator will give it you in pounds because you use pounds. 0.22375. The large one is going to be 50 for $10.99. So it's going to be £10.99, which is your total cost, divided by how many you got. You get an answer of 0.2198. So, which is the cheapest? Best value. I don't mean cheapest, best value, because obviously the cheapest is that, but you don't get as many. You want to get best value for money. As it happens though, the small one, surprisingly, usually you get it cheap, you get better value the more you buy, is actually the best value, because per one you're only paying 21.7 around pence. Okay, best value is the small. Okay, because that's the smallest number. Smaller than that, smaller than that. Okay, so buy small. Done. Clear the ink. Question 8. Here are the first 4 terms in arithmetic sequence. That means you're adding something on each time. What's this mystery number we're adding on each time? 3 to 10, you add 7. Add 7, add 7. Find in terms of n the expression for nth term. Trick is, because you're adding 7 each time, you put 7n, and then you hop back, you go back to what the term before would have been. So that's going to be -4, because you're on your number line, you're on 3, and you go back 7, you get to -4. So that means that you put a -4 here. That's your answer. Part B, is 150 a term in this sequence? You must explain how you get your answer. Right, so this sequence is of the form 7n minus 4. We want to know, does it ever equal 150 for any value of n? Okay, and remember, n is a whole number. So is there a whole number which makes this work? Is the question. Let's pretend it's an equation, because it is, and try and solve for n, see if it works. So add 4 to both sides. You get 7n equals 154. Divide by 7. You get, on your calculator, 154 divided by 7, 22. So yes, it is in the sequence, and we know that because when n is 22, i.e. the 22nd term, we get the answer. So 22nd term. Okay, clear the ink. Moving on to question 9. This looks pretty. The diagram shows a pattern using 4 identical rhombuses. Work out the size of the angle marked A. Can you see it? You must show all your working out. Well, I've never seen a question like this before. Okay, let me just take a second to think about this. Right, one thing we know for sure is these angles are all the same because the rhombuses are identical. Let's introduce a letter x. They're all x, okay? So, we know that's x, and we know that they're around a full circle here, okay? And we know that angles in a full circle add up to 360 degrees. Can you see we've got 25, 25, 25, 25? Show all your working out. Let's tell them exactly what we're doing. Plus 4x's, and we get to 360. Okay, 25 plus 25 plus 25 is 100. Minus 100, again, it's one of these linear equations we're trying to solve to find x. Okay, so 4x equals 260. 260 divided by 4, you can half it again, and you're going to get 65. Okay, so each of these angles is 65. Let's focus in on one of our rhombuses. So we know this angle is 65 degrees, which means that this identical opposite angle is 65 degrees. Okay, angles in four-sided shape sum to add up to 360 degrees. Therefore, these two missing angles that we're calling A are going to add up with 65 add 65, which is 130, to give you 360. 360 minus this 130 is going to give us 230. So A equals 230 divided by 2, which gives you A 115 degrees. Okay, job done. It's quite a nice question. Question 10. Sasha takes a music exam. The table shows the results that Sasha can get for different percentages in her music exam. Sasha gets 62 out of 80 in her music exam. What result did Sasha get? So we need to know what percent 62 out of 80 is. Okay, well, here's a cheat for you. Type in your calculator 62 over 80, or 62 divided by 80. Press equals. Okay, it might give you a fraction, so use the S and D button, and you get 0.775. That is this fraction as a decimal. To get it as a fraction, you just times by 100, or I just think, well, it's in here, so 77.5%. So she's 77.5, she got a merit, didn't she? Okay, well done, Sasha. Clear ink. Question 11. Simplify x to 7 times x to 3. So this is x times itself 7 times, x times itself 3 times. So if you put it together, you've got x times itself 10 times, 7 plus 3. Next one, m to 4 cubed. Well, cubed means you times m to 4 by itself 3 times. So it's m to 4 times m to 4 times m to 4. And actually there's a shortcut that you could have just done 4 times 3 to get the power, because you're adding these together. Okay. Next one, simplify. 36a f to the 8 over 12a to 5 f squared. So here you've got 8 f's lined up. Well, f times itself 8 times. Here you've got f times itself twice. Here a to the 1. But first off, let's do our numbers. 36 over 12, it's a calculator paper. If you want, type it in as a fraction, but they can both be divided by 12 to give 3 over 1. One of these a's is going to cancel from the bottom, so you're not left with any on the top. Okay, and this becomes a 4. 2 of these are going to cancel to give that as a 6. So you've got the answer 3 f to the 6 over a to the 4. Okay, that's your answer. Clear ink. Question 12. A circle has a diameter of 140 centimeters. Work out the circumference of the circle. Let's go for a diagram. That's 140. That's the diameter, which means it's all the way across. Okay. Work out the circumference. There's a formula called pi d. There's one called 2 pi r. They're exactly the same thing because d is 2r. Okay. So on your calculator, type in the pi button times 140 and tell me what you get. Shift pi you probably need to press, and press SD if you need to. We're going to have to round, so let's put this above 8. That's what came up on my screen. 3 significant figures, 1, 2, 3. We're looking at the 8 as what to do. It's above 5, so we round up. So this 9 is going to round to a 10, which carries forward. So 440 centimeters. Right, question 13. Axel and Lethner, I hope I've said these right. Apologies to anyone if I've not. Are driving along a motorway. They see a sign in the road. You know what? I see that sign in the road nearly every day. Anyway, the road sign shows the distance to junction 8, and we can see it's 30 miles, 26 minutes. It also shows the average time drivers will take to get to junction 8. That's nice of them. The speed limit on the motorway is 70 miles per hour. Lefner says, we will have to drive faster than the speed limit. I doubt that a sign would advise that. To go 30 miles in 26 minutes. Is she right? Is the sign wrong? Is the sign telling you to break the law? Let's hope not. Okay. Anyway, 30 miles per hour. 70 miles per hour. And we're comparing it to 30 miles per 26 mins. So what we really want to know, miles per hour, how far in 1 hour? So let's just do this in 2 steps. Divide by 26, that's going to give you how far you go in 1 minute. So 30 divided by 26 is going to be 1.153846. That's all recurring. Don't worry about that too much. Too exact anyway. That's 1 minute. We want 1 hour, so times by 60 on both sides. Times your answer by 60, and you get 69. It's a close one. 0.23 to 2 decimal places miles per hour. So is she right? No, it is 69.23 miles per hour, which is just less than 70 miles per hour. Okay. I'm lucky if I get anywhere near close to 70 miles per hour on my drive home. Question 14. The table gives information about the temperature, capital T, at noon in a town for 50 days. Okay, so someone has gone to the trouble of recording all this data, and this means that there were 6 things that were between 8 and 12 as a temperature. Write down the modal class. So the modal class is the one with the most measurements in. This has got 21 recordings in the class between 20 and 24. So you'd write down that is the modal one, the most common. Calculate an estimate for the mean temperature. Okay, so what we want to do to estimate the mean, let me just give you a bit of an understanding of what's going on. Here's your number line, or thermometer, or whatever you want to think of it as. We know that there were 6 temperatures that, because that's frequency, how many, that were between 8 and 12. So 2, 4, 5, 6. Let's pretend that's where they were. We don't know. Those crosses could be anywhere. Okay, they might not even be spaced out in the same way. So let's ungroup. Oh, we can't ungroup unless we mess up the whole board. Okay, but basically they can be anywhere in there. We don't know where. So as mathematicians, what we do is we say, well, tell you what, let's just assume that they're all in the middle. That'll keep it nice and fair. Yeah, some will be above it, some will be below it, but the middle is a nice guess. Okay, so what we want to know is the midpoint of each one. That's how we're going to guess. So middle of 8 and 12 is 10, middle of 12 and 16 is 14, 16, 20, 18, 20, 24, 22, 24, 28, 26. Sounds like I'm just saying random numbers if someone just turned the video on there. What we do now is we want to find the mean by adding them all up, all of them, and divide by how many there are. Now you've probably seen a formula written about this, okay, but I'm going to show you just from the table. So frequency, we've got 6 here, 8 here, 13, 21, 2. Add those numbers all together, and that will tell us in total how many we've got. So we've got 50 in total. Okay, so how many? That number is 50. Add up all of them. Well, this is just going to be an estimate, okay, because we're already saying we can't know exactly what the original things were that were recorded, but we can guess at 10. So what we're going to do is say, well, 6 crosses, we're guessing all 6 are at 10. So to add up 10 sixes, guess what? 10 times 6. Okay, so let's put a multiplier on each of these. So 10 times 6, 60. 14 times 8, crack your calculator on for that one. 112. 18 times 13, 234. 22 times 21, 462. 26 times 2, we don't really need a calculator, 52. You probably want to calculate for this bit, because to find out what they all add up to, we've done this thing for every single category. Okay, and you want to add them all up, so add up these numbers. So on your calculator, I'm not going to read them out, just feel like I've said about 259 numbers. 60. 920. So they all add up as an estimate to 920. And guess what? The examiner knows it's an estimate because he's put the word estimate, or she's put the word estimate. So let's find the mean. It's going to be 920 divided by 50. Do it on your calculator, and you get the answer of 18.4. And if you want to show off degree C, because that's what we're talking about, temperature. Clear the ink. Oh, part C. I hope I don't need what I've just got rid of. Kind of do. It's going to be a frequency polygon I've just seen. So, first interval. We're not doing integral now, no calculus. This doesn't mean take away, it's just so when I scroll down, we take it with us to help us with our table. Okay, so frequency of each. By the way, we are going to want the midpoints again, which I've just rubbed out, but they're not difficult to figure out. Middle of each class. Okay, and we also want frequency, how many in each. This would be laid out nicer on your actual exam paper. You'd have it all on one page for you. Okay, draw the frequency polygon. So we go from the midpoint for the frequency polygon to the frequency, which is already ready for you. You just have to figure out the scale. The scale is 2 little squares go up by 1. You can figure that out by just thinking how many to get up to 5. Okay, so we want to go up to 6 for the first one, middle 10, so you go 10, 6, put across, 14, 8, and you're going to put across 6, 7, 8 there. Done that one. Next one done. 18, 13 is going to be 2 down from 15. 15, there you go. 22, 21. At 22, right up there to 21. Well, here's 20, so there's 21. 26, 2. Quite a low one there. Okay, so there are all your points. You get your ruler out and you join these with a ruler. That is a frequency polygon, in case you didn't know. Okay, done. Question 15. Here is a right angled triangle. Work out the length AC. Give your answer correct to 1 decimal place. Okay, so it's a right angled triangle, and you've got a calculator in your hand. At least I have anyway. I can't see you, but you might do. Okay, we want to know this missing length. So what it is Pythagoras, and you want the longer side. So when I teach this, I say square, square, add square root. You might have seen it as a formula: a squared plus b squared is c squared. This just means you don't have to rearrange, does the job for you. So square 39, there is a video on this if you're not sure, is 1, 5, 1, 2, 1. Square 70 is 4900. Add them together. 6, 4, 2, 1, and then use your square root button. Square root that. So I press square root answer on my calculator. If you already had the answer in, and you get 80.13, 1 decimal place, 80.1 centimeters. Okay. Question 16. Solve this equation. Notice we've got f instead of x. Any letter will do for us, to be honest. We're good at maths, we know what we're doing. Expand out the first bracket. So you've got 5f minus 3. We'll leave this side fixed for now. F plus 10. We're not going to mess around with that until we're ready to. 5 times f is 5f. 5 times 3 is 15. It's a minus. Okay, the other side just stays the same. We want f on its own. We've got f on both sides. Take away f to get the f's where you've got the most of them, which is here. So 5f take away f is 4f. Now you're still trying to get f on its own. You have to get rid of this 15. Add 15 to both sides. Okay, so you're going to get 4f left on its own, 25. So calculator paper, you can do 25 divided by 4 on your calculator to give you an answer of 6.25. This is a more tricky one to solve. Okay, so what we need to do is something called cross multiply. We need to multiply up by something that will get rid of this 3 and get rid of this 2. If you multiply up by 3 times 2, aka there's a clue here, multiply it by 6, by everything, that'll do the job for you. So, I'm trying to think how best to explain this. If we multiply by 6 here, it's going to cancel as a fraction with the 6 and the 3. So you're actually going to get a 2. If you do it here, the 6 will cancel with the 2 and actually give you a 3. And if you multiply by 6 here, it's just going to cancel with the 6. So actually you can see that these go in front of the opposing brackets. So the first one you get 2, h plus 7. You have to have brackets, so you multiply the whole thing. 1, 5. Okay, now we expand out these brackets. 2h plus 14. And this one, they're separate here. Don't treat them as a double bracket, as I see some people do. Separate. Okay, now you can collect like terms. You've got 2h, you've got 3h, that's 5h. You've got 14, you've got take away 3, that's 11, and it equals 5. Yet again, we get one of these equations. So important you can solve these. It's one of the first things I teach in algebra. Okay, so you take 11 from both sides, and you get 5h left on the left, and you get 5 minus 6. If you're not confident, use a calculator. 5 minus 11, I answered my own question there. Divide by 5 on both sides, and minus 6 divided by 5 on your calculator is going to give you minus 1.2 as your answer for H. Okay, quite a tricky one. Just carry on with the skills of solving the equation, and you'll be okay. Complete the table of values for x cubed minus 4x. So you need to find a button on your calculator that says x cubed. It's just coincidental that this is x, and this is x, by the way. This just means put in any number. Say you put in 3, that'll do 3 cubed, which is 3 times 3 times 3, 27. Check it on your calculator. Anyway, that one's already been done for you. 27 minus 12, 15. So let's do the ones we actually have to do. My top tip for these tables is don't start here. Start on the right, where it's easier numbers, whole numbers. So you've got a calculator, so simply put this into your calculator. 2, and then cubed, and then take away 4 times by 2. Why? Because everywhere you've got the x, you're putting the 2 instead. And this is a little multiplier. So you put it here, you put it here. Okay, so 2 cubed, take away 4 times 2, and that gives you 0. 1. Okay, so 1 is going to go in, 1 cubed, take away 4 times 1. Do it on your calculator if you want, or you can do it in your head. It's just 1 take away 4, which is minus 3. Next one, minus 2. Minus 2 here, minus 2 here. Minus 2 cubed, make sure you use brackets for this. Minus 2 cubed, take away 4 times minus 2, you need brackets again. That also gives you 0. Okay, now we try minus 3. So put in the value of minus 3, put it in brackets and cubed. And I'm just going back to my last one by pressing the back arrow on my calculator, changing the 2's to 3's, and you get minus 15. Now we have to draw it, so we have to plot the points. How far down do I have to go? That's what I'm worried about. Let me just write over these so we can keep them with us. Okay, this is your x values and y values. So, ready to draw it on. I have to excuse that being over the top, I'm afraid. So, first point, minus 3 across, minus 15. So minus 3 across, down to minus 15, which is halfway between minus 14 and minus 16. It's in the middle of this one, which is there. Next one, moving along, minus 2 across and 0 up, so it's just there. Minus 1 across and 3 up, it's in the middle again here. 0, 0 is here. 1, minus 3, 1 across, 3 up. Minus 3, what am I talking about? Sorry. Minus 3, 3 down. 2 across, 0. And 3, 15. So we go up, right up to here, between 14 and 16. Right, now this is a smooth curve. Do not just do dot to dot. Quick demo. Here's a linear graph, which is y equals something to do with just x. Here's quadratic, something to do with x squared. What we're on now is a cubic, something to do with x cubed. Okay, something to do with it. And if you do A-level maths, you'll see a lot more of these cubics. So you've got to fit this shape onto here. Okay? So let's go for it. Something like that. Okay? It's not perfect. I'm just trying to give you the idea. There's lots of stuff going on this page now. But that's the answer for 2 marks. Question 18. ABC is an isosceles triangle. 2 angles the same, 2 lengths the same. Work out the area of the triangle. Guys, you can draw onto your diagrams. They don't have to stay how they are. What we're going to do, we're going to drop a perpendicular line there. Okay? And we're going to make it into 2 triangles from 1 triangle. So drop our perpendicular line down. And we're just going to think about this triangle here. So this triangle here has got an angle of 54 degrees. And for area of a triangle, we would really want to know about base and the height. So we can do half times the base times the height. We know the base, granted. We want the height. So this is actually what we want to find for our formula. So that's x. Okay, do we know this length across? Well, yeah, because it's the same as x. We've halved it by dropping our perpendicular line down. So that's half of 12, which is 6. What type of question does this look like? I've done videos on it. It's trigonometry. Check out SOHCAHTOA if you've not seen that yet. So we label up our triangle. Hypotenuse is always opposite the right angle, and they are right angles. So that's hypotenuse. Opposite is opposite your angle. So that's opposite. And the other one is the adjacent, which means next to the angle. So we've got adjacent to the angle. We want to know the opposite. So O and A is what we've got. So the formula we want is tan. This is an aid to help you remember the formula. The tan of an angle, that's theta, equals opposite over adjacent. That's the formula. So tan of our angle, which is 54, equals opposite, which is unknown, x, divided by our a, which is 6. So if we want x, we've got x over 6, which times by 6. And I've just swapped that round, by the way. 6 times by tan of 54. I've had people complaining they're getting different answers from me on some of these questions. Make sure your calculator is in degrees, which means it's got a little d. So you can go to Shift Setup if you've got the same calculator as me, and press DG, which is number 3. So we do 6 times by tan 54, close the brackets, and you get x is 8.258291523. Okay, what we need to do now is find the area. That is the height that we know. Okay, put it there. So we want to do the formula. Now we know that the height is that. Half times the base. If we want, we could just do 6 times that, but let's do the formula. Half times 12 times by 8 point whatever we just found, which I've kept in my calculator. Okay, so times by 12 times by 0.5. That gives us an answer of 49.54974914. Another rounding question, always read it again. 3 significant figures. These first 3, 4 doesn't affect it. Okay, and it is centimetres squared. Thank you very much. 4 marks. Question 19. I'm not a big fan of standard form, I'll be totally honest with you. 7.8 times 10 to minus 4 is an ordinary number. So I reckon your calculator is just going to give you that. Should we try a cheat? 7.8 times 10 to the power of minus 4. Yours might do, I don't know if mine does. So the cheat doesn't work because it just gives you that on the screen. Unfortunately, you can try it on yours, see if it works. So it means we start on 7.8 and we want to move back 4. That's because each time, by the way, minus is 1 over 10. And each time we divide by 10, which is the same as 1 over it, we move it back. So because it's negative, we move back 4 spaces. So keep the decimal point fixed, and we go 1. Better put some zeros in to keep us happy. 1, 2, 3, 4. So this is where our 7's move to. Our 8 moves next to it. And let's put in some placeholders. 0, 0, 0, 0.0. That's your answer. Write this number in standard form. So our key digits are 9, 5, 6. We want it to be between 1 and 10. So let's make it 9.56. And how do we change 9.56 into that? Well, we have to move it across 1, 2, 3, 4, 5, 6, 7. So 10 to the 7. Okay. Moving on. Question 20. In a sale, normal prices are reduced by 20%. A washing machine has a sale price of £446. £464. Okay. How much money is a normal price? So that's had 20% knocked off. So that's not 100%. Okay. We want 100%. We don't know it. How much do we know? Well, you started with 100 and you took off 20, so that's 80%. Okay, so that means we know that 80% equals 464, and we want to know 100. Well, let's find 10%. I know what you're going to do. Some of you guys, you're going to be like, yeah, I know how to find 10%. We divide by 10. Only if you have 100% already. Come on. We have 80%. So we divide by 8. Okay? 80, we want 10, divide by 8. So we divide 464 by 8, and we get 58 quid. If we want 100%, now you can do your little, what's that? Now you can do your times by 10. Okay? To get 580 quid. Okay, so that's your answer. That was the original price. Lots of people make mistakes on these. Seen it all too many times. Be very careful. Question 21. Tricky algebra question. We have to factorize this. You might notice that they're both square numbers. Okay? 4 is 2 squared. 9 is 3 squared. So if we were inclined to, we could write 2 squared x squared minus 3 squared. Well, these are both being squared. So we can put it together as 2x all squared. And it's take away something else squared. This is actually called the difference of two squares, which says it's going to be 2 brackets that add that, and this take away that. And if you try that for yourself, believe me, you'll get that answer. It's only 1 mark, so I'm not going to go into it too much. Make m the subject of a formula. Now, our problem is we've got m appearing twice. We've got m appearing on the left side and m appearing on the right side. Make it the subject of a formula means you want m equals, it sometimes gives you that clue, but you don't want any m's over here. Okay, not allowed. So let's first of all get all our m's on a positive side. This is a negative. Let's get them over here. So plus 3m to both sides. At least let's get some m's together. So that's gone. Am plus 3m plus 5. We don't want this plus 5 with our m's putting us off, so let's take 5 from both sides. I sometimes do this all in one go, but it's up to you. Okay, now how do we go from having m's separate to having m's together? This is the awesome part. What we can do is we can do a word beginning with f. We can factorize. Okay, so we factorize, and what we need is a plus 3. It's a cheat factorise that you weren't asked to do. You're doing it yourself to get m on its own. Now you divide by all this, a plus 3. We want m not being disturbed. So you get g minus 5 over a plus 3 equals m. And then at the end, just to please the examiner, let's write it the right way around. Swap how you write it. G minus 5 over a add 3. Okay, question 22. The diagram shows a trapezium. X minus 4 on the top, x plus 5 on the bottom, and 2x as the height. All the measurements are in centimetres. The area of the trapezium equals 251. It's very important. 351. Show that this. Okay, not a problem. Because we know how to deal with trapeziums. There's two ways you can do this. I'm going to use the formula. Area of trapezium. If you've got a trapezium that's A across, B down there, and you know the height, you do A add B, times it by the height, and half it. It's a really cool way to show that formula. Anyway, so let's do it with this. A half, A plus B. Well, that's A and that's B. So let's do x minus 4 plus, let's just do a different colour to show where it's come from. X plus 5 times by the height. Okay. Right, what we're doing here is we're timesing by 2, dividing by 2. So let's get rid of that. In this bracket, it's going to simplify to x minus, we got two x's, we got minus 4 add 5, which gives us a plus 1. And now this is where you might get a bit confused the way I've written this. You know that's a multiply. Okay, so it doesn't actually matter if the x is at the front or at the back. We're used to seeing it at the front, that's all, so I'm going to make that nice for you. Okay, as times out, we get 2x squared plus x. And now, that is actually the area. We know the area is 351. And now we're going to take away 351 from both sides to get what we were hoping for equal to 0. Work out the value of x. Right, I'm guessing, I can't think of two numbers off the top of my head that make that. And this is a calculator paper, so watch out for tricky questions like this that are very hard to solve. It means you might not be able to factorise, you might need to use the formula. So 2x, let me write it here and then we'll move up to it. 3. Okay, quadratic formula, you can go to your formula page, you'll see it. It says a quadratic formula, and it says if you have ax squared plus bx plus c equals 0, you can use the formula x equals minus b plus or minus square root b squared minus 4ac. I had to learn this when I did GCSE, all over 2a. Okay, now a is the number in front of x squared, so let's make a note of that. You can write them on the side if you want. A is 2. B is the number in front of x. Oh, you might say there's no number. There is, it's just not written. B is 1. C is the number on its own. Do not forget the negative here, because that should have been a plus. Okay, so minus 351. Now we put it into our formula. I've also done a video on the quadratic formula if you want to check this out. So B is 1, minus 1, plus or minus. I should do the rest in blue apart from what we're substituting in. I think that will help. Okay, right, we're ready. We've substituted in the b value. We want b again. We want it squared. usually want brackets for squaring it. So B is 1. 4 times A times C. Well, A is 2 and C is minus. Because it's a minus, we'll put a plus there because minus times a minus is a plus. And the number is 351. All over 2A. Well, A is 2. Messed up my colour code, but hopefully you followed that. Okay, you can type that in your calculator now. And before you say where's the plus or minus button, this is a shortcut to say both plus and minus, i.e. 2 equations. You need to do it twice. Okay, so first one, let's do it with a plus. Let's use that button to get the fraction up. And it's going to start with minus 1. Add square root. 1 squared, that's just going to be 1. Add 4 times 2 times 351. All over 2 times 2, which is 4, equals. Wow, that's nice. You get 13. Okay, so the plus version tells us that x is 13. That tells us we could have done it with factorising as well, if you wanted to. And now I'm not going to write the whole thing in again. I'm going to go back on my calculator, change the plus to a minus. You can't go wrong using this formula because it solves it even if you can factorise it still. 2 possible answers. Which one do you reckon we want? You don't want them both. Okay? You don't want that. Why? Because it was a length we were talking about. So we want the x is 13. We've solved it. Okay. Question 23. The table shows information about 1,065 students. Alina takes a stratified sample of 120 students by year group and by gender. Work out the number of year 8 female students in her sample. So, year 8 female is 134 because year 8 female. Okay, and we want that. That was from 1,065 students. So that's the fraction. We want that fraction of 120. Now on your calculator, you can use multiply for of. So it's 134 over 1065 times by 120, which gives you horrible decimal 15.0985. Don't put that as your answer. Think of a question. Alina wants to actually pick students out. She can't go into a classroom and say, right, year 8, I want 15.09 of you people now. It's not going to happen. Okay, think of real life as well in these exams. Let's round it. Let's go to 15 students. Okay, for 2 marks. Question 24. The diagram shows a large tin of pet food in the shape of a cylinder. The large tin has a radius of 6.5 as shown and a height of 11.5. A pet food company wants to make a new size of tin. It's not a bad idea. The new tin will have a radius of 5.8. Okay, 5.8 is a radius, so that's the circle. It will have the same volume as the original tin. So let me guess, how tall is it? Calculate the height of a new tin. The only thing that we don't know is how high this has got to be. And guys, we've come quite far in the exam, so let's use algebra, let's use x. Give your answer correct to 1 decimal place. So we want the volume of this original one. So the volume is going to be the CSA times by the height, or the length, or whatever you want to call it. Either way, it's 11.5. Now the area is the top area here. Okay, so it's a circle. It just so happens we're looking at it with weird perspective. It is a circle with radius 6.5. Okay, and we know the formula for the area of a circle is pi r squared. So you're going to do on your calculator pi times 6.5 squared. Pi times 6.5 squared, and that gives you an answer of 132.7322896. Okay, times that by 11.5, and you get an answer of 1526.421331. That is the volume. Okay. Remember, we've said that that's the old volume. New volume is again same shape, so CSA, cross-sectional area, times by the height. So it's going to be CSA, which will be different here because this circle is, what did we say, 5.8 as a radius. So the area is going to be pi times 5.8 squared, which is going to be 105.68 31769. Okay, that is what we've got here. Let's go to 2 decimal places so we can give our final answer to 1 decimal place. Times by our question mark, or x, or whatever you want to do. And we know that that volume equals this. So guess what? If we want this x value, or this question mark, we can divide that new answer by 105.68. So, in your calculator, 1526.421331 divided by 105.68. That gives you, it's not equal to. So, x equals 14.4433799, aka to 1 decimal place, 14.4 centimeters. You know what? If that company, if you were working for that food company, I think they'd be pretty impressed with you for finding that out for them. So good job. Well done you. Okay, question 25. It's a starred question, which means there's going to be some explaining, us showing our working out. A and B are straight lines. Line A has equation 2y equals 3x plus 8. Line B goes through a point -1, 2 and 2, 8. Where do the 2 lines intersect? What we're going to want to do is we are going to want to find an equation for line B and solve simultaneous equations. Okay, 3 marks, that's not much for 3 marks. I mean, it's a lot for 3 marks by the look of it, but let me think, is there a simple way? Simple. Do they intersect? Oh, it's just do they intersect. Okay, maybe they don't if it's just that many marks. Right, I'll stop talking about it and I'll start doing it now then. So, we've got a point. I'm just going to sketch it out. It goes -1, 2. That's our first point. And 2, 8. 2, 8. 8 can be up here. Okay, so this is the line B that goes through them. Okay, line A has the equation 2y equals 3x plus 8. Okay, fine. What we want to do is find the equation of the line B. So we want y equals mx plus c, where c is the intersect and m is the gradient. I think there might be a nice way to do this, but can't think of it off the top of my head right now. You guys might tell me. I'm sure you will, because you're good like that. Ah, what am I doing? Okay, whatever. 2 to 8. Okay, so from 2 to 8, it's gone up 6. From -1 to 2, it's gone across 3. So the change in y over the change in x is the gradient, which is 6 over 3, which is 2. Okay. Just trying to think how to show you this one. We're going to have to use the y minus y one, I think. I'm afraid. There's a formula to find the gradient, which is quicker than this. Not find the gradient, find the equation of the line. Y minus y1 equals mx minus x1. Where all this means is m is your gradient, and these are the point on the is a point on the graph. So you can use whichever you want. 2 and 8 might be nicer because it's both positive. So that's your x1, y1. So you're going to have y minus 8 equals m, which is 2, x minus 2. Okay, expand out this bracket. 2x minus 4, y minus 8 equals that. So y equals 2x, add 4 because we add 8 to both sides. That is the equation of line B. The equation of line A, 2y equals 3x, add 8. Well, if we rearrange, we can divide by 2. Y equals 3 over 2x plus 4. So that's the equation of line A. We want to know if they cross. I might have done this the long way, I do not know. So put the y's equal. So the two equations equal each other. I think I'm doing it more A-level style than GCSE, so I do apologise if you're struggling to follow this. Take away 4 from both sides, and it tells us that 3 over 2 times x equals 2x. Right, this only works when x is 0. Scrap that. Okay, when x is 0, then in this equation, you get that's 0, so y is 4. And in this equation, that's 0, so y is 4. So true, they intersect at 0, 4. Okay, maybe we could have done that an easier way. Leave that, guys, for you in the comments underneath. The diagram shows the triangle LMN. Calculate the length of LN. Give your answer to 3 significant figures. So the two formulas that you need from your book are shown for any triangle ABC. And the formulas are that A over sine A equals B over sine B, which equals C over sine C. That one is called the sine rule, hence why we've got sine, sine, sine. The other one we need in this case is called the cosine rule, which looks a little bit like Pythagoras' theorem. It says a squared equals b squared plus c squared, but then we've got minus 2bc cos a on the end, hence this cosine rule. So for the cosine rule, what we need is any old triangle, and we need this angle here, angle A. We need the other two lengths, B and C. And obviously this will just complete the triangle, but we don't need that length. For the sine rule, what happens is you've got any old triangle, and what it does is it pairs up the lengths and the angles, well, sine of the angles anyway, and says that the ratio of sine of the angle to the length is the same as ratio of the sine of the other angle to the length. Okay, so first of all, we think we want this situation for the cosine rule. So what we need to do is we need the angle between these two lengths. Okay, so we want this angle, let's call it x. So the problem is we don't have the opposite length for the angle x. So what we're going to have to do first is find the other angle y and then take it from 180 along with 136 to get x. So like we said from the sine rule, this says that the length, which we can say is 12.8, divided by sine of the opposite angle, which we have called it y, is the same as the 15.7 divided by sine of the 136. So I think it's a nice way around to think about this as a ratio rather than a formula. The two equal signs are just to represent three different formulas. To get y, we're going to times it by sine y. We're going to divide by 15.7 times by sine 136. But you basically just swap everything around and you get that sine 136 times by the 12.8 that we already had, divided by the 15.7 equals sine of y. So to get y, you need to undo sine. It's not multiply, it's sine of something, and the inverse to undo it is sine to the minus 1. So to get y, you're going to do in your calculator sine to minus 1 of all this stuff, 12.8 sine 136 over 15.7, and make sure that your calculator is in degrees to do this. So sine minus 1, big brackets, fraction button, 12.8 times by sine 136, close your brackets, over 15.7, close your big brackets, and that gives you that this angle is 34.49578,985. We want to take this and 136 from 180, and we get it's a very small angle actually, and this diagram isn't drawn to scale, it should be smaller than this. This angle is actually 9.50 to 2 decimal places. So what we're going to do now is we're going to use the cosine rule. So I'll erase what we've just been working on so we can focus on the cosine rule. And what we have is the angle inside, which is angle A, and we've got the two lengths either side. So I will label this one up for you. I didn't label the last one because the letters might have changed around. It's just really nicer to think about the opposite lengths and angles and getting confused with letters. Okay, so this is your angle A, and B and C can go either way around, doesn't matter. So B, C. So in the formula, this is going to be A because it's opposite A, and this is what we want. A squared equals B squared, which is 12.8 squared, plus C squared, which is 15.7 squared, minus 2 times by 12.8 times by 15.7 times by cos, these are all multipliers, of the 9.5 angle degrees. So you can literally put that whole right hand side into your calculator. 12.8 squared plus 15.7 squared minus 2 times 12.8 times 15.7 times by cos of 9.5, and that gives you 13.922, etc. Straight away square root it. We only want the positive version because it's a length. So A is 3.73123, etc. We wanted three significant figures, 1, 2, 3. So A equals 3.73 centimeters. The 1 isn't going to round it up. Okay, clear the ink off. Question 27. histogram shows information about the times in minutes that some passengers had to wait in an airport. Okay, and the question says, work out the percentage of passengers who had to wait for more than 1 hour. Now notice your timing is in minutes, so over an hour is anything over 60. So this is what we're talking about, but we're talking about it as a fraction. This is a fraction of the whole thing. Okay, so first of all, let's figure out how much this represents, then the whole thing, then we've got ourselves a fraction. So for each one, we are going to find the area, because the area represents a frequency in a histogram, and there is a histogram video that I've just put on today as well. So the first one has got a frequency density of 0.6. We're going up 0.2 at a time on this scale. So it's going to be 0.6 times by the class width, 30, because it's 90 to 120. 30 times 0.6 gives you 18 for that first area. The second one is going to be a width of 30 again, 60 to 90. This time it's 1.8 sort of frequency density. 1.8 times 30 is 54. The next one, halfway between 40, 50, 45 to 60 is 15 wide, and it goes up to 4.8. So 4.8 times by 15 on your calculator, which is going to give you 72. The next one, that's 30 to 45, 15 wide, goes up to 7. 7 times by 15 is going to give you 105. Hope you can see this okay on the board. 20 to 30 is 10 wide, and it goes up to 10.246, 10.8. So it's 10.8 times by 10. We can do that in our head, 108. The last one is from 0 to 20, so it's 20 wide, goes up to 12. 20 times 12 is going to be 240. You can do that in our head as well. So we're adding up for the total 240, 108, 105, 72, 54 and 18. If you do that on your calculator now, like I'm doing, you're going to get an answer of 597. What a strange number. Hope we've done that right. Okay, now we're interested in the 54 and the 18. So do 54 add 18, and that's 72 people that had to wait for over an hour. So the fraction is 72 out of 597. That's what it was asked for. If you want, you can whack it in your calculator, and it will simplify to 224 over 199. Okay, and it wants percent. So in your calculator, do it as a decimal. Look up percent. I've got a feeling I might have added something up wrong there, but I'm sure you guys will let me know if I have. Just thinking it might have been nicer if it added up to 600. Maybe it does, maybe it doesn't. Anyway, it's going to be 12.1%, because if you press SD on your calculator, you get 0.1206, 12.1% to 3 significant figures. If it doesn't tell you what to round, always round to 3 significant figures. Okay. Question 28. AOC here and BOD here are diameters of a circle centre O. Prove that triangle ABD, which is this one, and DCA, doesn't matter which way around really, DCA are congruent. Congruent means the same triangle. Okay, in maths, congruent means identical. Now, not identical in terms of the same orientation, but if we could spin that around, it would go bang on top of the other one. So how are we going to prove it with maths? Well, if we prove that they're all the same lengths, then we're done. Okay? Now, because these are two diameters, what we can say straight off is that AC and BD are the same since they are both diameters. Okay, so that one's okay. Next one. We know that in a semicircle, the angle from our circle theorems, and I've done a circle theorem video, is 90 degrees. So check that out if you're not quite sure about that. So angle BAD, 90 degrees. And same reason, angle ADC, because it's angles in a semicircle. Okay, ADC. The reason is angles in semicircle equal 90 degrees. So they're the same. If we prove one more angle is the same, then we're done. Unfortunately, there's another circle theorem that we can use that says this angle is the same as this angle because they're subtended from the same arc. I've also done that in my circle theorems video. So you could say angle ABD equals angle ACD. And also, for the same reason, you could have going from this arc maybe, that these two angles are the same, but they're not actually in the triangle. So just ignore that. Since angles subtended from the same arc are the same. Okay, now if you've got a triangle, so angles in triangle add to 180 degrees. So the third angles are the same in each because they've got to add up to 180 in total. So the final point that we're going to say, three angles the same and one length the same, therefore congruent. That proves it. If you define one length to be the same, then all the angles are also the same. It has to be the same triangle that you're making. Okay? There's no other way to do that. So, that is the proof complete. Obviously, you would set it out a bit neater than me. All this stuff would have gone underneath. But I wanted to keep it all on the same page for you. I hope that's been helpful. And I hope it helps you achieve maths. And you're enjoying your revision. You're starting to enjoy maths. I think when you start to get good at maths and really understand what's going on, you start to like it. That's what I believe anyway. Thanks for watching. Goodbye.